Hi, in this video, I'm going to show you the other diagnostic test for an OLS estimation. We're going to begin with the multicollinearity test first. Let's rerun the regress command first, regress, and then the MPG is our dependent variable, weights and foreigns are the independent variable. So we run this regression and we are going to test for the multicollinearity among the variables. The command is estat VIF. Estat VIF. So press enter. So you can see this is the variance inflation factor for each and every variable in the model, and the average VIF is 1.54. So we can conclude that there is no multicollinearity problem in the model, because the rule of thumb is the value of VIF must be below than 5 to indicate a low correlation. But if you get a value of 5 to 10, then probably you are going to have a moderate correlation among the variables. But please make sure that you get value of always below than 10, because above 10 there is an indication of a very strong collinearity among the variables. Now we are going to do the second diagnostic test, which is model misspecification test. The first test under model misspecification test is omitted variable bias test. We are going to use Ramsey reset test. So after we run the regression, we are going to write this OVTES, which is the omitted variable test. Press enter and you can see this is the Ramsey reset test for omitted variables. So the null hypothesis is model has no omitted variables because the probability value is greater than 0.05. So it is not significant. It means that we cannot reject the null, indicating that it has no omitted variable bias. The second test for model misspecification is to check for an outlier. So we are going to use the command extremes. For those of you who have yet to install the command, so you can try to install it first. SSC INSTALL and then the word extremes. SSC install extremes and press enter, and once it is installed, then we can use this command to detect for the presence of outliers. So how to check for an outlier using extreme command? So we write extremes commands and then the variable MPG, weight and foreign. Then after extreme, we need to put the option IQR, because we are going to use this extreme as using interquartile range. So let's put that first, IQR, which is interquartile range, and let's see the result. Remember, using interquartile range, we are going to detect for the presence of outliers when the observation lies 1.5 below the first quartile or 1.5 above the third quartile. Remember, we are going to distribute our data from the lowest until the highest into 4 quartiles. So the first and third quartile will be the threshold that we are going to look into. 1.5 below IQR first quartile and 1.5 above third quartile. Any values below that or above that threshold will be considered as an outlier. So here Stata gives us observation number 71 with IQR 2.286. It means that this observation potentially is an outlier because it lies, this is positive value, so it lies above the 1.5 of third quartile. Another way to look for outliers is to check the standardized residual. So we must predict the STD receipt. This is the name that we give to our new variable. We will see here standardized residual. So the command here, you must put R standard. So predict we ask Stata to predict the new variable standard residual. This is the name of the new variable. So what will be the observation? The observation under standard residual variable is the R standard. The word is R standard. Press enter, so you get this standardized residual variable. And we are going to use extremes again, and we write the new variable name, which is standardized residual, std resid. So we are going to tell Stata to check this standardized residual observation using extreme command whether there is any outliers. So if there is no option whatsoever after the last variable, when we use extreme command, extreme normally will show us the lowest 5 and the highest 5 among the standard residual. So extremes command is going to list to us the lowest 5 and the highest 5 of the observations. And we know that standardized residual must lie within +3 or -3 to be considered no outliers. If there is any standardized value that is higher than +3 or lower than -3, so we can consider the outliers is present. So -3, we don't see any -3 here. They are all bigger than -3. And +3, so we can see one observation, which is observation 71. It is 4.3, which is greater than +3. So again, this is reinforcing the previous finding here. Observation 71 is shown to be an outlier in our dataset. Finally, we come to the final test, which is to test for the residuals normality. What we need to do now is to predict the residual first. So we predict the resid. Resid is the name of the residual, and what will be the observation is the residuals. Predict resid, residual. So you get this resid variable containing observation of residuals. So we are going to run 3 normality tests. First is skewness and kurtosis test, SK test on the variable resid. So we can see the probability here is significant. Joint test for both skewness and kurtosis. So the probability is smaller than 0.05. It means that most likely our residual is not normal. Let's try Jagbera test on residual. The command is jb resid and press enter. So we can see here the chi-square test has this very small probability value, 0.000 something. So we can say that it is strongly significant, hence we can reject the null hypothesis of normality. Again, we find similar results here, significant p-value indicating the residuals are not normal. And finally, we have Shapiro-Wilk test for residuals normality. So the command is swilk resid, and we can see here Shapiro-Wilk W test for normal data. The probability is also significant. Hence, we can conclude that the residuals in our estimation are not normally distributed. Thank you.